Okay, thank you for coming. This is a talk slash workshop on the topic of smart contracts on Ethereum. Um, it was announced in the schedule in English, and I think weird. Okay, I heard some English-speaking people talking English. Okay, so we keep this in English. Um, it's rather late, and usually you have something like Hacker Jeopardy at this time. We're doing smart contracts, or perhaps we could also do, yeah, let's stick to the schedule. So, as I said, this is a workshop, so please, to speed it up a little, there is a browser plugin called MetaMask. We will need that later. It is an interface to the Ethereum network, so between your browser and the Ethereum network. So while I do this boring introduction talk, you can already install this exciting plugin. Yeah, so blockchains. Blockchains are these weird, this weird world where people buy expensive hardware and actually even manufacture specialized hardware and lease airplanes just that they get the new hardware 1 week earlier than their competition, and then they waste tons of electricity to produce virtual coins somehow. And then there are these other people who who try to scam common people into investing millions of dollars into their project, which then somehow doesn't work out, and it's a project on some tropical island instead. And there's also this company which was called, which used to be called Long Island Iced Tea, and they renamed themselves into Long Blockchain, and their stock price increased fourfold over a day or something like that. And then there are people who want to put blockchain into everything: blockchain in your car, blockchain in your house, blockchain in your dog. And when you take a closer look at their blockchain, you realize for 99% of the cases, that the blockchain isn't really an essential part of their project, or it doesn't benefit from having a blockchain. But there is something below all this, and I hope we can talk a little, or I can bring this a little closer to you in the next hour. And the thing is that wasting electricity in proof of work is not essential for blockchains. There's something called proof of stake, which is currently still under research, but it looks promising that it can completely replace proof of work, and so you don't have a waste of electricity. And most of these ICO tokens are scams, but creating a token and having a crowdfunding is actually can be an interesting way to fund a project if it's done right. And there actually are some good use cases for blockchains, and I will tell you about 2 use cases, and one of them is called Swarm, or more general, the topic of a decentralized incentivized file storage. IPFS is also developing something along these lines. And the idea is that you use BitTorrent for backups. That might sound weird, because usually you just use BitTorrent for downloading movies. But if you use BitTorrent as a general file storage system, then you have 2 problems. Unpopular files are deleted, and if a file is deleted from BitTorrent, then it's gone, or at least it's much harder to get the data the fewer people it have. And your personal backups, I mean, who would care to keep your personal backups? And the second problem is that some people only download, they do not upload. And it's actually, I mean, you don't have an advantage in uploading. So you could modify your software to just download. And blockchains could solve these two problems. And the Swarm project tries to do that. And the first idea is that you just pay people for storing your files. So you ask someone to store your files. Actually, you ask the whole network to store tiny chunks of all your files in a distributed way. And you pay for that. So people get a reward so that you can rent out their hard disk. And of course, as in these scam ICOs, they could just take your money and run away and delete your files immediately. But they have to put a deposit into a smart contract. And if you request the file later on and they cannot provide it, then they lose their deposit. So they have an incentive to actually keep your data. And the second thing is that we talked about this problem that some people only download. So even if they have your file, they might give it to you only very slowly because they don't want to waste their uplink capacity. And that can be solved by just paying them to do that. So this is done in a way such that you always measure the data going in one direction on the link and going in the other direction on the same link. And if there's an imbalance, then the person who downloads more has to pay for that data. And in general, designing these mechanisms where you pay, where you have to pay, where you reward or where you punish people in cryptocurrencies, this is called crypto economics, or more general, the mathematical branch of mechanism design. And a blockchain allows you to add that to an existing protocol. Then the second example is HTTPS or SSL without trusted CAs. The CA, so certificate authority problem, is a well-known problem. And currently, as far as I know, SSL certificates are tied to host names only via these CAs. And this means, so a certificate authority signs the key that belongs to a server or to a host name. And they are supposed to check the ownership of that domain, but it's not part of the protocol. So they can do it, but they don't really have to. And they can easily create fake certificates and basically disguise as anyone. And there are many of these CAs out there. And but a blockchain-based system could solve that problem. And it could solve it by just making this domain ownership check, or at least the distribution of domains and the transfer of domains, part of the protocol. So the blockchain stores who owns which domain name. And of course, so who here is, so people are identified by public-private key pairs. So a public key is tied to a host name. And if you want to sell it, you can only sell it, or if you want to transfer it, you can only transfer it with a signature from that key. And the certificate can be stored directly together with this, with the name in the blockchain. And the Ethereum name system is built like that. It's a hierarchical DNS-like system of names for Ethereum. And in a similar way, you could build a corruption-resistant land registry, so land ownership registry. Of course, in Germany, this is not such a hot topic because land registries usually work quite well. But there are countries where you can just go to the authorities, pay a little sum, and then you own a piece of land you're actually not supposed to own. Okay, when are blockchains useful in general? They are useful. I'm sorry, this really doesn't work well. They are useful for applications that are already digitized. So blockchains have a problem with interfacing with the real world. So you can't, an application on a blockchain actually cannot download a website. It cannot check if a package was delivered correctly. But if you already have a digitized application, BitTorrent as an example, then it can be useful. In addition, participants have to have conflicting goals. If everyone has the same goal, then yeah, you don't need something to resolve disputes. And also, there should not be a central trusted party. If there's a central trusted party, that party can just run a server, and you put everything on that server, and it works much better than with a blockchain. And so I think these three characteristics must be set, and in addition, they have to be much more important than no, sorry, how do I say that? So if you run it on a blockchain, that it will be much more expensive, and it will be much slower than running on a traditional server. So it means these three topics here have to be as important to you, such that these higher costs and the reduced performance are not a problem in comparison. Good. So what is Ethereum? Ethereum is, in essence, a database or a virtual computer, a database with stored procedures. And this virtual computer is built on a decentralized network, a peer-to-peer network where everyone can just join. And if you join, your computer forms seemingly chaotic connections to other computers, and out of this network emerges a single virtualized computer. And everything that runs on this computer is transparent, so everyone sees what everyone else is doing. It is manipulation resistant, so it is hard to change anything that was done in the past, or almost impossible. Authenticated, this means that everyone who interacts with that virtual computer is known, in the sense of has to send a message signed with a private key. So you always know where a transaction originates, and it's publicly accessible. So anyone can go to this network and use this computer. Okay, we will go more into detail later, but are there any questions already? I see a lot of question marks. No? Okay, actually we will not go more into detail on these parts. Instead, we will just treat Ethereum as a single computer that somehow emerges out of this peer-to-peer network. I won't go into detail how that actually happens, because we want to write smart contracts, and we only have 1 hour. Okay, what are smart contracts? Smart contracts are neither smart nor are they contracts, although the name might suggest otherwise. It is just a term that was coined many years ago, and it kind of stuck for this use case. Smart contracts are just programs running on a blockchain, nothing else. Or you could also see it as stored procedures in a blockchain-based database. So there's no law aspect, no AI aspect, it's just simple programs. Yeah. Okay, that was the introduction already. So let's try to write some smart contracts. I put instructions at this link here. It's the same link that is at the end of the description in the schedule. The GitHub one, exactly. And it starts by telling you to install this browser plugin. I will walk you through that. So yeah, these links are important later. And if you want to know more, here is Solidity is the high-level language I'm developing, and Crypto Zombies is an interactive tutorial to learn that language made by someone in the community. Actually, I didn't really register there because you have to sign up with username and password, which is really weird in the blockchain space, but somehow they do that. But I heard that it should be nice. Good. So I'll install MetaMask in Chrome here, although I will use Firefox later. Okay, that's the website. I click on the extension. So MetaMask connects your browser to a single computer that is connected to the peer-to-peer network, and you have to more or less trust that single computer. So if you want to do serious things, then you should not do it like that. You should run your own, at least light client that directly connects to the peer-to-peer network and not connect to some other computer that connects to the peer-to-peer network. But for the workshop here, it's really convenient. Okay, I installed it. Now here's this fox icon in the top right corner. I click on it. It will tell me to accept some legal stuff. Yep. And now ask me to create a new password. Now these are 12 words, which are of course now known to you. So I don't have to copy it somewhere else. So I mean, this is all just for testing stuff. So when you uninstall, when you uninstall the plugin later, then you don't have to copy it. Now I have one account, and it tells me that it's on the main network. So this is really important. Switch it from the main network to Rinkeby. Someone who knows Swedish might correct my pronunciation. So Rinkeby is a test network, and the reason why we're using a test network is that everything you do on Ethereum costs money. That might sound weird, but it's the only way the blockchain community has come up with that prevents DOS attacks. So I can go to this computer and ask it to do computation tasks for me. And if just about anyone could do that without paying money, then it would be easy to DOS that computer to bring it to a halt. And because of that, for everything you do, you have to pay with a unit called gas. And on this test network, this gas is, or ether, as it is also called, this is worth nothing and can be easily obtained. Now, and since everything costs ether, we have to get ether first. This is the most complicated part. In this link, there's a way to get testnet ether via Twitter. If you don't want to do that, then we can use IRC, and I just give you some ether. So I'm on this channel called Smart Contracts in the same network where the Easterhegg channel also is. If you go there and paste your address, which can be, so you can get that by clicking on these three dots and then click on copy address to clipboard and just paste it there, and I will send you some ether. So I will switch to Firefox now, which contains a MetaMask plugin that actually has some ether. I can also increase the font size a little. Okay, there we have one address. Now what I do is I take my MetaMask plugin, I click on send, I put the address there, and I send one ether, and I click on next. And what now happens is it signs the transaction, or tells me to confirm that it will sign the transaction, and There's some more details which are probably too small on the screen, so I click submit, and then I can, when I click on pending here, I get the same transaction in something that is called a block explorer. And this is just also, again, a single node connected to the peer-to-peer network, which you can trust, but you can also use your own one. But this is, again, convenient to use. And note that it says Rinkeby here. This is important because otherwise you're on the wrong network. So the URL is rinkeby.etherscan.io. And now when we look at this pending transaction, it says pending, which means it is not included in the blockchain yet. This will only happen after some time because there's this mining process that determines the order of the transactions. And once this worked, which should be around after 15 seconds, okay, took a little longer this time, then we have, success here. And I just sent someone 1 Ether. Don't know who it was. Yeah, okay. And now let's take a look at this, the details here. If you use the Twitter method to get testnet Ether, there will also be a link that leads to this page, I think. So there's a transaction hash. This identifies the transaction. It says the transaction worked. This is the number of the block it was included in. So a blockchain is a sequence of blocks which are linked to each other and where each block builds on top of the next. And this is just the number of the blocks starting from the first one. It has a timestamp. It has an address where the money was sent from. This is just a 160-bit hex number, which is roughly a public key. And then it has a to address where the money was sent. The amount of money, 1 Ether. Ether has, I think, 10 to the 18 subdivisions. So it has the smallest amount you can send is 10 to the minus 18. Then there's this gas limit. We talked about that earlier. So everything you do costs gas, and gas is kind of a measure of the amount of computation that needs to be done. And we will run smart contracts later. So we will run programs, and as some of you might know, you cannot in general predict what programs will do. And because of that, we have to specify an upper limit of how much we want to run there. So if for example, if it has an infinite loop, then you want to provide an upper limit so that it doesn't really run forever, because that would, And that's what this gas limit is for. And 21,000 is the smallest number you can have because the transaction itself already costs 21,000. And then it used up all this gas. So gas that is not used up, you get refunded gas that is not used up in the end. And you can also specify a gas price. That is something that is most confusing for some people. That's basically the exchange rate between gas and Ether. So if you want to pay more for your gas, then your transaction is more likely to be included in the next block, because the miners who create that block receive this gas as a fee. And that is the actual amount of Ether that the transaction cost. And nonce is just something that is, it's not important. No, it's so a transaction is always atomic. There's no parallelism, so it runs. I didn't understand the question. What do you mean by it's 18 blocks away, and where did you get that 18? Oh, sorry, yeah.
Does it mean it needs 18 blocks? Maybe 18 blocks.
Where did you get this number 18 from?
Until the smart contract has been executed. What does it mean with the Ether gas price binding? Please explain it again.
Okay, gas is just a unit of resources that are
That's a
consumed.
fuel. I need to fill the tank with fuel that the machine is running. That's how I understand it.
So gas is the number of steps the machine runs, for example.
Hmm.
It's a little bit more complicated because you also take into account memory and yeah, but more or less it's the number of steps the computation runs. And the gas limit is the maximal number of steps you want to wait for it to terminate, to finish. And the gas price is the amount of ether you want to pay per step. If you pay more per step, then miners are more likely to process your transaction early.
That's yeah, exactly. That's what I want to know. Okay.
Did that answer
Yeah,
it? Or
I got it.
okay. So in Bitcoin you have transaction fee and gas, but since Bitcoin transactions are more or less consume more or less the same resources all the time, you only have the simple transaction fee per transaction. But in Ethereum, transactions can be more or less heavy with regards to computation, so you have to scale the amount of resources, amount of computation it does by the gas price. Okay, more questions? I'll just hand out some more money. I think the instructions already contain the next step, do they? You can also send money between yourselves once you have some. Okay, and once you received some ether, MetaMask should show a balance here, which is non-zero. Okay, more people in need of ether, more people in need of answers. Okay, then please interrupt me if you need more ether or have questions. And the next step now is to go to a website called remix.ethereum.org. This is an online browser-only IDE for writing smart contracts on Ethereum. It shows a rather complicated smart contract. We will replace that by a simpler one, and you can find it. Whoops, where was it? Yeah, you can find it here, E1 simple contract. And let's just copy that and paste it into the IDE. Okay, let's try that again. What you can also do is you can look at addresses here in the block explorer. And it would tell us if this Tesla person really didn't get any or just wants another one. Oh, yeah. Did someone else receive something? Does it work at all? Okay. So we should get a pending transaction here, actually. Yep. Okay, so let's take a look at Remix. Question? Ah. Okay. On the left here, you have a kind of tree view of the files. In the middle, you have the source code, and on the right, you have some tools. This is the source code of a smart contract. It starts with specifying a version for the programming language, and then you have this contract thingy, which looks similar to a Java or C++ class. And that's, yeah. And the thing is that, so smart contracts have a storage area where they can store permanent data, and only the smart contract itself can modify its own storage area. And we use that to map member variables. So the stored number is a unsigned integer value that is permanently stored on the blockchain, and public means that you can, you have a convenience function to, it generates a getter function to read the value. Then you have a function called name, which is also publicly visible. It is pure, which means it neither modifies nor reads the state, the blockchain state, and returns a string. The string is my nickname. And then you have a function called store number. It takes an unsigned integer and stores it inside this member variable. What is not visible here is that unsigned integers in Solidity or Ethereum are 256 bits wide. Any questions here? Basic understanding questions. Store number is RP. We will see. What does it do?
Just a question, what store number is basically, is it visible AP, or can it be called from somewhere?
Yes, so all functions that are public can be called from outside. They can be called from a contract like the one you just created. They can be called from an account like the one you just created, and they can also be called from other contracts. And what we will now do is we will compile this contract and deploy it on the blockchain. If you click this autocompile, it autocompiles, which is quite nice. It would tell you any problems with the source code immediately. So, yeah. We have a warning here, which we ignore. Okay, let's take a look. Yeah, okay, the gas requirement is high. The reason is, so it estimates how much gas a function takes, and it says that the name function can take arbitrary amount of gas, and the reason is that the string is a dynamic data type, and you don't really know the length, although you actually know it, but yeah. Okay. The run tab here allows you to create smart contracts and call functions on smart contracts. This environment dropdown here is important. It tells you it uses injected Web3. Injected Web3 means it uses MetaMask, and it says it uses the Rinkeby network here. So everything you do down here will have an effect or will create transactions on the Rinkeby blockchain. You can also switch to JavaScript VM. In that case, it will use a simulated blockchain that only exists in the browser. That's the account we will send from. That's the gas limit, the maximum time we want functions to run. And we don't want to send any ether with the function call that we could do here. Okay, you select the smart contract here, my named account, and click on create. Now MetaMask will pop up and ask you to confirm this transaction you want to send here. It again tells you the gas limit was not different because there's actually some work to be done. We confirm that. And now we wait a little. It will tell you some details here, which don't look nice. So this is a pending transaction now. Oh yeah, it just got confirmed. It says contract published here, which should also mean that no. Yeah, something broke in my system here. I'll try it again. So something should appear down here for you if it worked. What did I enter under account? I just used the default. There's just one thing for me. Yeah, your contract is visible in Etherscan. Yeah, okay, but Remix doesn't see that. I'll just reload. Sorry. So Remix has some glitches. Does it work for you? Does anyone have problems? Okay, then I'll try a trick. And I go to Etherscan. I see that, so when a contract is created, the address at which that contract is created will only be determined after creation. So, but I can copy that contract, that address here, and just tell Remix, oh, I know that a contract of that type is present at that address. I paste the address here and I click add address. And now I get the same interface you get when you, or I would get when the contract is correctly created. Okay, now I have 3 buttons, 1 button per function. Store number is red because it triggers a transaction, because it changes something in the database, in the blockchain. Name is blue because it's just a query function, it just reads something from a blockchain. If I click it, it will still query the Ethereum node, but you won't have to pay anything for it because it's just reading data. And it should display Chris Ethier. That's the string that is returned in this name function. And if I click on store number, if I click on stored number, then I get the value that is stored in this member function. Should be 0, exactly. And now I can store a different number here. And if I click the button now, it will again ask me to confirm a transaction. And now we have to wait a little. Yeah, that looks better. It now tells me a link to Etherscan where I can take a look at the transaction. So that's what I meant when I said it's not as fast as a non-blockchain solution. Yeah, okay. Remix now tells me that it already worked, although Etherscan still has it pending. And now you have this details and debug buttons here. When you click on details, it will tell you details on the transaction. If you click on debug, it will fire up a debugger. Ah, okay. Sorry. Perhaps that worked. You won't believe me when I tell you it worked perfectly fine when I tried it yesterday. Yeah, okay. We can also go to Etherscan and use tools and utilities here and click on Remix Debugger. This is similar to the Remix Debugger you would have seen, but it doesn't resolve local variables. But it shows you how it actually executes the bytecode that is generated here. And so the slider is just the point in the execution. Because you can't do anything about the transaction anyway anymore, you can easily go back and forth through it.
No.
The question was if all of these instructions cost 1 gas. No, some of them are more expensive, some of them are less expensive.
It will block.
Again?
The will block of that cost gas. Not every single instruction.
So every single instruction costs gas, but some of them are more expensive than 1 gas.
Okay.
So a approximation to gas is the number of steps, and if every instruction would cost 1 gas, then it would be just number of steps. But it's not exactly that, because a multiplication is more expensive than an addition, for example.
Okay.
But if you click on step detail here, then you see the remaining gas here. And if my screen was larger, I could stretch through it, and we would see that it gradually decreases with every single step. And it tells you that the amount of gas this single instruction costs. Good. More questions. Did you try to change the name here? Who changed the name? So let's do something more interesting. Let's deploy the Easterhegg contract. Okay, the Easterhegg contract is a token contract. So it has a mapping. It has a mapping that contains the balances for every conceivable address. So every address is assigned a balance. All the balances are initially 0. And it has a total supply, the number of Easterhegg tokens in existence. So this is a standardized contract interface called ERC20. And the idea is that as long as you keep to this standard, you can just use any possible and even future token together with your application. So if someone creates a new type of token and your application is compatible with the ERC20 standard, you can just use that token with your application. And each token has a name, a symbol, number of decimals, and Then you have a function where you can query the balance of an account. It just returns balances at that point. Then you have a function called transfer, where you can send tokens to someone. You can send a number of tokens, so this value, to someone. And the way it works is that it, of course, checks that you have at least that money. Oh yeah, msg.sender. I said earlier that every transaction in Ethereum is signed by the person who initiated that transaction. And it actually goes, so, and smart contracts can call other smart contracts. All these contracts are done synchronously. And msg.sender always contains the address one higher up in the call chain. So msg.sender is always who called this function. And if you call the function transfer, then you voice the intent to send a number of tokens to an address. And because of that, we can use msg.sender here. So, and this is the interesting part. You do not need to know any cryptography for that. Usually you would have to sign data, you need elliptic curves, signatures and all that, but this is all abstracted away. It's just a computing platform that knows who called which function, and by that you don't need signatures. Okay, we check if the sender has at least that amount of tokens. We reduce the balance of the sender by that amount. We increase the balance of the recipient by that amount, and we emit an event. So this is to send a signal to the outside world that something happened. This is just logging or something like that. We said the transfer happened from here to here with that amount of tokens. And then we have a special function that is not part of the official ERC20 standard. It is marked internal, which means that it cannot be called from outside. And this can be used to create new tokens. So it increases the balance of the sender by 1 and increases the total supply by 1 and emits a special transfer event from the 0 address to the recipient. And then we have also, again, another public function which is not part of the standard. You can call that to request such an egg or an heg only until Monday. Yeah, let's deploy that contract and try to call that function. So I will now create that smart contract and I will tell you the address where it was created. And then you need to copy that source code and use the add address feature. Okay. Yeah, that's annoying. Okay, now the way to go is, okay, why is it? Yeah, the testnet is not in best shape today. Because, I mean, that is something that can always happen in a blockchain. The node we are connected to here already says the contract was created, and the node Etherscan is connected to did not yet have that information. So, but the older transactions get, the more reliable they are. And already after 10 minutes, you can be quite sure that it will never change. Okay, this is, I will paste that into IRC and I will also make a comment on the gist. Okay, now what you do is you take, I mean, you do exactly the same thing as I. So you copy paste the source code here, of course, and then you check that it says Easterhegg here. You paste the address into the add address field and click on add address. Smart contracts. Okay, you have to remove this space here, it seems. Smart contracts on hackint is. Okay, my time estimate is a little bit off. We didn't get. Okay, we can check some information here. Decimal 0, name, Easterhegg that worked, symbol, EHG, total supply should be 0, yep. And I can request an egg. Let's see what happens. Gas estimation failed. That happens. The error is not the best. So that happens because of this require. Oh, no, of that require. Yeah, this happens because the request hack function calls the name function on the sender. Okay, and of course the sender here doesn't have a name function because it isn't even a smart contract. It's just a public private key account. It's not a smart contract. So this call fails. And when a call fails, then everything in the transaction will be rolled back. And it, depending on how it fails, it might cost all the gas you provided. And the more gas you provide, the more will be consumed. So it can't really estimate the gas. That's the reason. And so this means an external account cannot request an egg here because it doesn't have that name function. So only accounts that have the name function can request an egg. Okay, so what we need to do is we have to create an account, smart contract of course, that has the name function. And an example is here this named account, which is below here. It has the name function. So we take that and create a new file here on this plus icon. Paste it here and we implement it.
Question.
Yeah?
File name is can be anything, right?
Yes, doesn't matter. So we only have 5 minutes left, but there's nothing after this event. So
I think we can extend a little bit. Is it okay? Only problem is you might have some experience from the lab. Yeah. I thought it would be right. Yeah, sure.
So one thing, I said earlier that this is compliant to the ERC20 standard, and this blockchain explorer has support for that standard. But it's much nicer if I tell, the smart contract is given in source code form, but it's compiled to bytecode, and only the bytecode is sent to the blockchain. And because of that, this blockchain explorer doesn't know the source code; it only knows the bytecode. But it's much more useful if we also tell it how the source code looks, and we do that by just copying everything here. I can't copy two things at the same time. We go to that address here. That's something only I have to do now, because we already reused the same thing. Okay, it knows it's a smart contract. It has the code here, but it's just bytecode. But we can use this verify and publish feature here. And we need the source code for that. There's a half-automated version using the Swarm project I mentioned earlier, but it's not implemented in Etherscan yet. Now we have to tell it the contract name and select the same compiler version. So what it will do is it will take the source code and recompile it and check whether it matches the bytecode that is stored on the blockchain. Yeah, centralized services. Okay, that worked. And now we have the source code here. And we're still in the verify setting. If we go to the account now, it will give us more options. It will first tell us the source code, and it will allow us to read smart contract, which is similar to what we can do in Remix. We can call functions that are query only. And it doesn't yet know that it is an ERC20 contract because that is actually triggered by this event we saw. So if Etherscan sees this transfer event, then then it will see that it's an ERC20 token. Okay, for that, someone needs to get an egg, and that can be done with the request egg function. Did someone already find out how it works? So we need to call that function from a smart contract that has a name function. So let's create a smart contract that has a name function and also add a function that will call that request function. Now, okay. Okay. So we need to tell this named account contract the interface of the Easterhegg contract, and that can be done by just pasting it here. Okay, I could have done that easier, I guess. And now we pretend that at this address of the Easterhegg contract, we actually have a Easterhegg contract. So that's a explicit type conversion. I think this is also linked somewhere. And then we call EH.requestHegg. Okay, did everyone get that?
Do we need to use your hash?
You need to use the same address here. I mean, that's the address I pasted into the chat. Okay, now if we create that, okay, we have multiple contracts here now in this file, so we have to select the correct one in the dropdown and click create. It might be that Firefox that the plugin doesn't work really well in Firefox. Are there more questions while we're waiting?
So to conclude all this, for example, if the get hack is, for example, a ticket for the Easterhegg conference,
Yes.
you could completely deploy the ticket sales into the blockchain and have a fully distributed blockchain ticket sales solution, for example?
If you can associate physical persons with public keys.
Yeah, okay. Uh-huh.
So you can check the tickets at the entrance. Yeah,
I see.
yeah. In principle, yes.
But
So and this because we have this transfer function, the tickets can also be transferred to other people. And since the transfer function can be called by smart contracts, you can actually also sell the tickets. And selling means you have an atomic transaction that both transfers the ticket and transfers the money in the other direction at the same time.
uh-huh. And not only send sale tickets from the centralized organization, but also people could sell their tickets to each other?
Yeah, sure.
Yeah,
Sure.
okay. But then in the end, that means you said each transaction here costs a little bit of money or
Yeah.
a little bit of ether. That means depending on if you start the ticket sale in December of 2017 or now, you have a different dollar value that you need to even get the ticket by via this method? Because ether
because of the
has a different
the
value.
exchange rate of ether. Yes, yeah. I mean, it kind of it also depends on how much activity you have on the blockchain. Because if you have more activity on the blockchain, then the gas price will increase because there's more demand and there's only a limited amount of transactions that fit into a block. Because of that, the gas price will increase. And if you have, I mean, if there's almost no activity, you can also get away with a very, very low gas price, and because of that, a very, very low fee.
Okay.
So it depends on multiple factors. So the question was if CryptoKitties makes
Make
it too
too
expensive.
expensive, yeah.
So
to develop
CryptoKitties
on a
was a
chain.
very popular application in December, which caused the gas price to increase tremendously. And yeah, so these are factors. So Ethereum is working on scaling solutions, which means a way such that it does not get more expensive if the blockchain is used more heavily, but that will still take some time.
Other question: what is your personal environment toolset? Are you using Parity and Visual Studio Code, or
To be honest, I
development?
don't use blockchains very much. Because I'm not an application developer. I work on Solidity. So I develop the high-level language. And so in general, the Ethereum Foundation is a non-profit organization with the goal of developing and extending the Ethereum platform, and we do not develop application on top of the platform. We do develop some very basic application like the Ethereum name system, but not non-basic applications.
Okay.
And I mean, the smart contract language doesn't need a blockchain. It only needs a virtual machine to run on. Because of that, I don't really use blockchains that often. So I copied the contract address now. And now I can use it in Remix. Yeah, so we have a named account at that address. Let's check whether the name function works. It works. It doesn't return a string now. It returns a hex-encoded version of it. That is a limitation that will be removed with the next version of the compiler. But for now, it's, bytes 32 hex-encoded. And if I click on getEgg now, it will call the request function and hopefully be assigned an egg. And what we can do now is we can take a look at the Etherscan interface. Another question?
Did the rest get the new address from the new contract, or is this not necessary?
I know. So everyone can deploy their own.
So
of
the
these.
named contract.
So
everyone can
okay,
do
the
it?
idea is that every one of you creates this named account contract and fetches an egg,
Right.
basically. Okay, so and now if we take a look at the transaction here, it says this transaction included a token transfer from the 0 address, so the token was created, to this address. And now if we can take a look at this ERC20 Easterhegg token, and Etherscan will provide us with a shiny interface that lists all the transfers. So yeah, some of you successfully got some of these tokens. And we can get a list of token holders. Yes, some already have 2. Can even have a chart. Yeah. So and this is just a tiny glimpse into what is possible with smart contracts, and especially due to the fact that smart contracts can interact with each other and their interfaces are public. You can yeah, you mentioned CryptoCatties earlier. This is a kind of funny gamified thing where you can breed cats, and they have a genetic code that is stored on the blockchain, and if they mate, then this genetic code is combined to form a new cat, which then looks different but shares some properties. And but it's everything is stored on a smart contract on the blockchain, so people can create new smart contracts and interact with that existing smart contract. So people took that game and extended it with a version where you can also buy hats and put them onto your cats. Or there's another game where so all these cats have different feeds that are derived from the genetic code, and now someone created a game where you can have cats race against each other, and if they have a panther feed, then they are faster and things like that. So, and this is of course just stupid games, but if you imagine that with real useful applications, that could get rather interesting. Okay, I have some more things we can do with this egg contract, but I'm not sure if it doesn't make sense. I think everyone is rather tired. We could do an ad hoc session tomorrow, perhaps, to continue if there's demand, interest. Not sure if that is, how is that? Okay, we can put it in the schedule, right? So, yeah. There was another question?
Was that a smart contract was something that automatically got activated when something happens in the blockchain? That was always my...
That is commonly stated, but it's wrong.
Yeah,
so
it's just wrong, right?
Yeah.
Okay.
So, news articles always say, oh yeah, smart contracts are contracts that automatically trigger when something happens and then they settle some stuff. That's wrong. So
yeah, like stop loss contracts.
Yeah. So smart contracts always have to be pushed.
Okay, so you always have to first set them up and then call them.
Yeah.
Okay.
Yeah. They do nothing on their own.
Okay.
Having said that, of course, because it's you can of course create a smart contract to pay people to trigger your smart contract when certain things happen. For example, at certain points in time. Right?
Yeah, okay.
And that way the smart contract themselves do not get active on their own, but because we have humans who like to get money, we can make use of these humans to activate the smart contracts. And so what is also important, smart contracts cannot read anything from the environment. They cannot download websites. Everything has to be fed into them. And the reason is because smart contracts are executed on every single computer that is part of the peer-to-peer network. And these executions have to come to exactly the same result in the end. And because of that, you cannot have any external input that might be over some flaky connection. They have to be, basically mathematical functions which always yield the same result. More questions? Yeah, in the back.
Hi. So you had to specify the interface for the get hack function. So does it mean that whenever I want to call a contract from another contract, I have to somehow get the interface to that contract?
Yes, I mean Yes, I mean.
Okay, thanks.
You want to know what that contract does anyway, right? So you don't even want to know the interface. You also want to know its semantics. And in the case of ERC20, for example, the semantics are kind of implied by the interface, but you can actually create a token where this transfer function. You can create an ERC20 token where the transfer function does some weird other things. So, and this is actually also something interesting. So, on Ethereum, you can easily create new currencies, new tokens, and they can have very weird mechanics. For example, random tokens being destroyed every day, or random tokens being created every day. You can have something that is kind of similar to basic income using tokens on Ethereum. Yeah.
Yes, I have a question. You said that a smart contract is executed many times, and then only when the results are equal, then it is put into place. I always understood that the miner that was writing the next block, right, that he would execute the contract one time on that machine where the mining is done, and then he would receive an ether. He would receive the gas or the ether for executing that contract one time.
Yes, so
I didn't think
miner,
it was a parallel process.
That's correct. So the miner executes the transaction, determines the outcome, and then sends the block containing the transaction to everyone else. But everyone else re-executes and re-verifies that that was actually the correct outcome. And if they come up with something else, they just drop the block. So that's where the security comes from. Everyone re-executes everything all the time to check.
Yeah, and it's a common misconception that the miner actually checks anything of the block. So basically, miner just needs to find a hash that matches the difficulty, and most.
Yeah, it depends on how you define mining, but usually it also includes executing.
And mostly, the miner just trusts another node or another person.
In a mining pool, yeah. But someone has to execute the transactions in the mining pool.
Okay, but when the smart contract is executed on the blockchain, then the results are written to the blockchain and then they remain there. So it's not interacting with any other system on the internet or something like that. No. So, okay.
Yeah, there was another question.
If all the functions have to be deterministic and everybody has to get to the same result, how do you implement a function that, as you earlier mentioned, kills random tokens?
It has to be pseudo-random, of course. Yeah, so it cannot be actually random, but that's the case for most of the randomness in computers. So. Yes, one way to get something like randomness is using the hash of the current or hash of the previous block that is accessible from the smart contract.
Okay, so
you take
some kind of outside unpredictable input, but that is universally agreed on in the network?
I mean, it is written inside the smart contract. The smart contract says take the hash of the previous block.
Which is unpredictable.
Yes, so
Within
miners can manipulate it to some degree. So it always depends on how it's used, but it's some kind of randomness. Yeah. So if you have, I don't know, if you have a lottery and you have a 0-1 chance of winning, then a miner can run it, and if the miner doesn't win, they just try again. And for such cases, it would be bad to use the block hash. Yeah. I think there was another question.
Yeah, I understand that the transactions and the data that come into a smart contract are attached to that contract or part of that contract's chain. So if I have variables that are defined within the contract, maybe a struct, and I'm adding to this, then that data is associated with this contract somehow. The point I'm wondering about is if I publish a new contract with a bug fix, let's say, and then and my application relies on the data that was submitted to the previous version of the contract, what happens to that data when I publish a new version of the contract?
Okay, that's an important point. So as I said earlier, so for example, this total supply, the only point where this is referenced is here at the bottom where a new egg is created. That's the only way to change that variable because it's imprinted into the code. And furthermore, once a smart contract is deployed, it is impossible to change its code. So you cannot publish a new version of the smart contract. Of course, you can change the source code and publish a new contract, but it would be a different contract with a different storage area.
So my question is about a production application that might be using Ethereum and the smart contracts that relies on transactions that are ongoing or maybe that happened weeks, months, or years ago. There's going to be a need to change the contract or fix a bug. It'll never be perfect.
Yeah, that is a tricky thing about blockchains. So you want to have some kind of way to update the code, but then the question is who is allowed to do that? And so if you have a single person who is in charge to update that contract, and so I mean updating the contract, I mean usually you think of updates in, oh yeah, small patches applied, but it's just, I mean it's new code. It can be totally different. It can change the behavior drastically from one transaction to the next. And there are methods to do that, but it's always a trade-off. Do you want to allow that or not? And it's also so by default code cannot be changed, but there are ways to kind of update the code and keep the data.
So maybe to summarize this differently, we have this database, this global database, and it's once something is in it, it's immutable.
Is the microphone switched on?
It does look like it. Is this on? Okay.
Okay, sorry.
Oh, the stream is on. Okay. So the usual thing you do when you have immutable data is to create a new copy and do whatever you need to do to that copy and agree that this is the new version. So is there do you need to form some kind of consensus to switch to the new version of your contract? So
yes, there are several ways to do that. I mean, if you separate code and data, then you can deploy new code that references the same data. You can also create snapshots and recreate the same data at a different place. But it's always a trade-off between costs and convenience and security.
I think this is what goes in this direction here. Okay.
Okay, shall we go to the lounge? Okay, then thanks a lot. As I said, so yeah, if you have more questions, just approach me. I will only be here until tomorrow evening, so if you have questions, ask them tomorrow, and perhaps we do a continuation of this workshop tomorrow. Okay, thanks a lot.